Today we'll be working on the Unit 6 review. The Unit 6 review covers notes from sections 14.0 through 15.2b. And so those are the notes that you want to have out and be referencing while you're working on this review. Remember that the video just helps you do this paper, but you want to be going back into your notes so that you can practice doing extra practice problems from these sections. You also want to be using your notes to help you do these problems. So let's see, question number 1 says, evaluate the function y equals 2 times 3 to the x with the following. And so you're given 3 different values for x that we're going to substitute in for here. Remember, whenever you see the word evaluate, it means you're probably going to be plugging something in. So in the first one, I'm going to have y equals, and then I'm going to write down this exactly the same that it looks. But instead of putting down the letter x, I'm going to plug in the number for the problem. So on this one, I'll be plugging in the number 0, and then on the last one, I'll be plugging in the number -4. And so I'll be getting answers for each of these questions. Remember, when you do these, you want to follow the rules for PEMDAS. So PEMDAS says you're going to do exponents first before you multiply. So this one would turn into y equals 2 times 243. So for this one, I'm going to get y equals 486 as my answer. You know that you'll be finished on these ones when you get down to just one number. On B, anything raised up to the power of 0 is equal to 1. So I'll get y equals 2 as my answer for that one. And then on this last one, 3 to the -4 means that you do 3 to the 4th, but then it needs to move into the bottom of the fraction. So this right here is going to be moving down into the bottom of the fraction. So the 2 will stay on the top, and then 3 to the 4th is 81, but it's not going to be 81, it's going to be 1 over 81. So the 81 will move into the bottom of that fraction. Anytime you have negative exponents, unless it's otherwise stated, you want to make sure that you're keeping your answer as a fraction. So these would be the 3 answers for these 3 questions. Again, some things to keep in mind for question number 1. I made sure that when I was plugging in the numbers, I was plugging them in for the letter x, and then I made sure when I simplified each of the problems, I simplified it down until there was one number left on the question. On question number 2, we're matching each of the tables that are given with the exponential function. There's a couple different ways that you can go about doing this. Remember that the numbers in the function, so the numbers that you're given over here, when you plug in a number for x, f of x is the number that you get out for the problem. And so you could plug every one of these numbers in and see what numbers you get out for them and match them up that way. One thing that you might notice about this question is that all of the numbers that go with 0 are different. So on this one, when you plug in a 0, you should get out a 1. On this one, when you plug in a 0, you should get out a 3. 0 should give you 2, and then 0 should give you 1/2. And so we can probably figure out which ones of these go with which ones of these, because all of these values are different. So I can do the work over here to see what's going to happen. You could do the work for each of these underneath, or if you needed a separate piece of paper to do the work for them, that would be helpful as well. On this one, let's start with B. So on B, when I plug in the number 0 right here for x, 4 to the 0 power is going to give me 1. So on this problem right here, when I plug in the number 0 for x, I get out the number 1. So that's how I know that B is going to match with this table up here, because on this table, when I plugged in a 0, I got out a 1. You could draw a line connecting them. I'm just going to write the letter B next to this table so I know that that's the table that goes with B. Let's see, we can do this one next. So on this one, 3 times 2 to the 0 power. 2 to the 0 power is going to give me 1, and then 1 times 3 is going to give me 3. So when I plugged in a 0, I got out a 3. And so out of the tables, on this one, when you plug in a 0, you get out a 3. And so that's how you know that your second table on the list is going to be the one that matches up with C. We can do this one next. 2 times 3 to the 0 power. Anything raised up to the power of 0 equals 1. And then 1 times 2 would give me 2. So on that one, when I plugged in a 0, I got out a 2. And so that's how I know that this table is going to go with A. And then it is true that D would just be the one left over, but let's make sure that we show the work that justifies that. 1/2 times 3 to the 0. Anything raised up to the power of 0 equals 1, and then 1 times 1/2 would give me 1/2. And so that's how I know that that would go with this one, because when I plug in a 0 on this one, I'm supposed to get out a 1/2. If any of these numbers matched, so on a different problem, if there were two tables, let's say, for example, that both went with 0 to 1 and 0 to 1, you might have to then plug in another number in the problem to see which one goes with which. So to truly make sure that these tables matched, we should also be plugging in the numbers 1 and 2 and 1 and 2 on all of them to make sure that you get out the numbers for y that you're supposed to get out, or for f of x. But for this problem, because all 4 of the y-intercepts were different, I was able to use these values right here from the table to help me figure out which one of the equations matched up with which one of the tables. Question number 3 says to find the common ratio, so that's going to be the first part of each question. And then it says it wants us to find the next 3 terms in each of the following sequences. So there's 2 things that we're being asked to do for each of these 2 problems. The first thing they want us to do is they want us to find the common ratio. So remember from your notes, common ratio right here, that's the number that you multiply by on each of the problems to get from one number to the next number in the list. And then when it says to find the next 3 terms, we're going to use whatever the multiplier was to figure out what would be the next 3 numbers that come after 108. And on this one, what would be the next 3 numbers that come after 4.5. So first, we're going to start by finding the common ratio. To make a 4 turn into a 12, you multiply by something. To make a 12 turn into a 36, you multiply by the same thing. And to make a 36 turn into a 108, you multiply by the same thing. And so on this problem, to make each of these numbers become the next number in the list, you're multiplying each of them by 3. 4 times 3 gives me 12, 12 times 3 gives me 36, and then 36 times 3 gives me 108. So that means that my R, or my common ratio on this problem, would be the number 3. To find the next 3 numbers in the list, I would use my calculator, and so I'd be doing 108 times 3, and getting the next number in the list. I'd be doing that number times 3, and then the last number times 3. So the next 3 numbers in this list, using a calculator to multiply it out, would be 324, 972, and then 2,916. So both of these are answers to the question, because this question asked us to find 2 things. As soon as you know what the common ratio is, you can find out as many of these numbers as you want to, because you would just keep multiplying by that number over and over again. On letter B, to make a 36 turn into an 18, by the way, notice that it's getting smaller. That's going to be part of how you know that your answer for this one has to be either a fraction or it has to be a decimal. When the numbers are getting smaller, it doesn't mean that you're subtracting something. It means that you're multiplying by a fraction. You can think about it like division, but the definition of common ratio says that it's the number that you're multiplying each of them by. So we'll make sure that we write our answer to this one as either a fraction or as a decimal. To turn a 36 into an 18, you cut it in half. To turn an 18 into a 9, you cut it in half. To turn a 9 into a 4.5, you cut it in half. So for this one, you can write down that the common ratio is either 1/2, or if you wanted to, you could write it as a decimal. And so it doesn't matter which way you write it. Both of these are fine answers to the question. And then to find the next 3 numbers in the list, you would take the last number that you were given and then multiply it by this common ratio. So 4.5 times 1/2 would give you 2.25. That would be the next number in the list. The number after that would be 1.125. And again, I multiplied this by 1/2 to get this. And then I'll multiply this by 1/2 to get 0.5625. And so that would be the 3rd term following the list that was given up above. So those would be the next 3 numbers in the sequence. In question number 4, you're given a function. It says when a ball is dropped, this is the function that models the height and feet of the ball after each bounce. If you look at the number inside the parentheses, you see how it's 0.7? Because that number is less than 1, it means that the ball is bouncing up higher every time that it bounces after it's first initially dropped. Remember that the 30 is the height where it started, and then this is how high it goes each time after it bounces. So you do want to make a note that the number out front of your parentheses, this 30 right here, that's always going to be your starting number, or in this case, your starting height. To the nearest hundredth, what's the height of the ball after the given bounces? So for this one, they want to know how high will the ball be after it bounces twice, and for this one, they want to know how high will the ball be after it bounces 3 times. And so to find these, we can plug them into the function that we were given. So for this one, f of 2, or the height of the function after 2 bounces, would be given by 30 times 0.7 to the 2nd power. And for this one, f of 3 would be given by 30 times 0.7 to the 3rd power. You could figure out how high the ball was going to be on any number of bounces by plugging in that number for the number x right here. So for this one, when I type this into my calculator, it wants me to round it to the nearest hundredth if necessary. On this one, when you type it in, you get 14.7, and it's being measured in feet. So you want to give your answer in feet. And then on this one, when you type it into your calculator, you get 10.29 feet. And so those would be the answers. The first one you didn't need to round to the nearest hundredth, but the second one, that's to the nearest hundredth, because hundredth is 2 decimal places. And again, this process could be repeated to find the height of the ball after any number of bounces. Question number 5, we're given equations. We're asked to solve for x. It's suggested that we do it by equating exponents. There's a couple of different ways that you can do these problems. When I'm doing the work for letter A, or B or C, I notice that the exponent is up in the x is up in the exponent. So the number that I'm trying to solve for, x, isn't a regular variable like normal, it's an exponent that I'm trying to solve for. So to make my life easier on these problems, I'm going to start by dividing by the number that's out front, and that'll help make my numbers be a little bit smaller. So on this one, I'll divide both sides by 3, and so that's going to give me 4 to the x is equal to 16. I didn't need to put the parentheses around the 4 anymore because there wasn't a number out front, but if you wanted to keep the parentheses here, it wouldn't be wrong. It's just that you don't need it. So you could stop here to figure out what the answer to the question is, or the other way that you can do your work is you can rewrite this side so that the bases match, because that lets you figure out what the exponents are. Some people right here are able to stop and notice that x should be equal to 2, because if 4 to the x is equal to 16, you're asking yourself 4 to what exponent gives you 16 out as your answer, and so you might be able to see that 4 squared equals 16. The process of equating exponents, though, says that you're going to rewrite this number with this number as your base. So you're going to write 4 to the x power is equal to, that part stayed the same, and then 16 you could rewrite as 4 squared, and then since the 4's match, you would know that x had to be equal to the number 2. And so you can use that process of equating exponents to solve the next 2 problems as well. On B, you'll start by dividing both sides by 9. Doing this helps make your numbers just be a little bit smaller. 288 divided by 9 gives you 32. And so again, there's 2 ways you could finish this problem. You could stop here and just plug numbers in for x and try to think about what the number would be for x. The other way to answer the question is to rewrite 32 so that it has 2 as your base. So you're going to say 2 to the x is equal to, and then you're going to change 32 so that it's a 2 raised up to an exponent instead. And 32 is 2 to the 5th power. So here, since the 2's match, you know that x would have to equal 5. Some students feel like the last one here, letter C, is a little bit more challenging because it has a fraction. Remember, though, our first step was to get rid of the number that was out in front. On this one, I have a fraction out front. So when I have a fraction out front, I'm going to multiply both sides by 4, because when I multiply a fraction by the number that's in the bottom, top and bottom cross out with one another. On this one, I do have to keep the parentheses around the 1/2 since it's a fraction. 1/16 times 4, 4 goes into 4 once, and 4 goes into 16 4 times. So I would have, oh no, that was right. So I'd have 1/4. So you're trying to figure out when you raise 1/2 up to some exponent, you get 1/4 out as your answer. So you could stop here and just try to think about what it would be. The other way you could do it is you could write it by equating the exponents. So 1/4 is 1/2 raised up to the 2nd power. 1 squared gives you 1, 2 squared gives you 4, and so that's how for this last problem you would know that x had to be equal to 2, and that would yield the correct answer to the question. Question number 6 gives us a function to consider. So for this one, I'm going to be doing y equals 4 to the x power. And part A wants us to complete the table for the function above. Make a note that anytime you're filling out a table for functions, unless it's otherwise stated, you want to make sure that all of your answers that you get out here for f of x are given as fractions, not as decimals. So we're going to write even for these negative ones, we're going to write our answers as fractions. I usually start with the positive numbers. So when you're plugging these numbers in, you're plugging them in for the number x, or for the variable x right here. So 4 to the x, 4 to the 1st power would give you 4. 4 to the 2nd power would give you 16. And then 4 to the third power, 4 times 4 times 4, that would give you 64. Some of these numbers aren't going to be able to fit on our graph when we graph it, but we're still going to fill them in on the table. When I plug in the number 0, anything raised up to the power of 0 is equal to 1. And then you want to remember what happens over here with your negative numbers. 4 to the negative 1 is 4, but the negative on the 1 flips it down into the bottom of the fraction, so it's going to be 1 over 4. 4 to the negative second would flip that into the bottom of the fraction, so that's going to be 1 over 16. And then 4 to the negative third would flip that into the bottom of the fraction, so that's going to be 1 over 64. You want to make sure that you remember from the day that we did this in class that negative numbers being plugged in for an exponent do not make these numbers negative. Most often, they make them be a fraction, so it causes whatever the value of the expression would be to flip upside down. Part B wants us to graph the function. And so some of these numbers we will be able to fit on the graph, and then some of them just won't fit. 0 goes with 1, 1 goes with 4. I'm not going to be able to fit those two on the graph because they're too tall, and that's fine. Negative 1 goes with a 4th, negative 2 goes with a 16th. These numbers over here just get closer and closer and closer to the x-axis, but remember, it's never going to cross over the x-axis. I connect them with as smooth of a curve as I can. And when I draw the graph, I want to try to, well, there's a little bump there, but I want to try to make sure it doesn't look like it's crossing over the x-axis. When I look at this graph and when I look at the function values, question C asks me, is the graph increasing, decreasing, or is it constant? So these numbers are very small numbers, and then they start to get bigger, 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 bigger. And so that's how I know that the graph is increasing. If it was decreasing, the numbers would be getting smaller, and so the graph would look like it was coming down. Question D wants me to identify what the y-intercept of the graph is. Remember, the y-intercept is the point where the graph crosses the y-axis. It's always the point that's buddied up with the number 0 for x in the table. So for this one, my y-intercept is going to be the point 0, 1. And the last question, questions on this part, E and F, ask you about end behavior. And so there's a little trick for end behavior that your teacher might have shown you in class. Remember that this is positive infinity, this is 0, and this is negative infinity. And then on this side of the graph, this is positive infinity, this is 0, and this is negative infinity. And so this is just one way to help you with end behavior. On question E, it says, as x approaches infinity, so that means as x goes to the right, they want to know what does y approach. So as my x values are going to the right here, they want to know which of these three does it look like the graph is going to. See how the graph looks like it's going up forever and ever and ever? As x goes to the right, so from the middle of the graph, as you move your pencil to the right, x is approaching positive infinity. So as x approaches infinity, y approaches infinity. You can put the little plus sign out here in front if you want to, but if you don't put a plus sign out in front, it means it's positive, so you don't actually have to write it down. Question F says, as x approaches negative infinity, and so that means as x goes to the left, what does y approach? And so from the middle of your paper, as you move your pencil to the left, the graph is getting closer and closer and closer to the number 0. So y approaches 0 as x approaches negative infinity. These describe the end behavior of the graph. Question number 7 asks you some questions about a graph. The difference with this one is that you're not actually drawing a picture of the graph, you're just being given some information about the graph and being asked to answer questions about it. Consider the exponential function that passes through the points 0, 4 and 1, 16. So these 2 points up here, 0, 4 and 1, 16, they're given to you already. So you know 0 goes with 4 and you know 1 goes with 16. So you already know that those are 2 points that are on the graph. Question A wants you to start by writing an equation of the exponential function of the form y equals a times b to the x. Remember a, this number that goes out front, that's always your y-intercept. It's always the beginning point on your graph. So up here, 0, 4, that tells you what your a value is going to be. So I know this function is going to start off with y equals, and then my a is the number 4 because that's where it begins, or that's the value that it starts at. The next number, the number that goes inside the parentheses, is the number that I'm multiplying by to make the number 4 turn into the number 16. And so to make a 4 turn into a 16, you want to think about what you have to multiply it by. So to make a 4 turn into a 16, I also have to multiply by 4. So that's how I would come up with this equation right here. They happen on this problem to both be 4s. This one's a 4 because this one was a 4. And then this one's a 4 because 4 times 4 gives you 16. So there's a different reason why each one of those is the number 4. But this would be your equation for that answer to the question. B wants me to evaluate the function for 2, 3, and 4. So remember, I already knew 0 went with 4. I already knew 1 went with 16. And now they want me to figure out what number does 2 go with, what number does 3 go with, and what number does 4 go with. So I could use my equation to figure this out and plug the numbers in to find my answer to the question. Or I could truthfully just continue the pattern as well. And so either way that it works for you is fine. If I plug in a squared, 4 squared is 16, and then 16 times 4 is 64. But notice how that just continues my pattern of timesing by 4. That means that when I plug in a 3, I would get out 256. And when I plug in a 4, I would get out 1024. And I encourage you to go back and actually plug those in on your calculator so that you can practice evaluating the function for these numbers so that you know how we got them. The numbers are going up, which means the graph is increasing. D asks if the graph represents exponential growth or exponential decay. Because these numbers continue to get further and further away from 0, that means that the graph represents exponential growth. And then the last question on question 7, E, asks us to state what is the y-intercept. And so remember, the y-intercept was given to us in this problem. The y-intercept in red here, it's always the number that goes with the number 0. So for this graph, your y-intercept would be the point 0, 4. Question 8 on page 2 of the review starts out with a question that's asking us to sort the functions below into the chart based on if they represent exponential growth or exponential decay. And so you'll want to remember from your notes, if it represents exponential growth, that means your b value is greater than the number 1. And if it represents exponential decay, that means your b value is going to be between 0 and positive 1. So we usually say that for decay, our b value is going to be a fraction, but it could also be a decimal that's between 0 and 1. Remember, in a function, your b value is the number that's inside the parentheses. It's the number that has the x on it. So I'm looking at the number on all of these questions to help me decide if it's growth or decay. I'm looking at the number that's inside the parentheses. I'm not worried about the number that's out front because that doesn't tell me how the function's changing. That tells me where the function starts. 0.3 is in between 0 and 1. So that means that this function, because this decimal isn't bigger than 1, it means that that graph would represent decay. For B, the number inside the parentheses is the number 8. 8 is greater than 1, and so that means that B would represent growth. For C, I'm not looking at the number out front, I'm looking at the number inside the parentheses. 0.7 is not greater than 1, and so that means that that graph would represent decay. For D, 1.04 is greater than 1, so that graph would represent growth. 0.94 is less than 1, so that graph for E would represent decay. And then 0.99 is less than 1, so that graph would also represent decay. So you do want to make a note on this one for question 8 that you're looking at the number inside the parentheses, you're not looking at the number out front. Question number 9 is a true and false question. It says the amount of bacteria per day can be modeled by the exponential equation y equals 1500 times 1.04 to the x power. And so this is a series of true and false questions that were being asked about this. Remember though, you do need to show work, so you can't just decide if the question's true or false. You want to make sure that you show work that justifies your answer. Let's see. So question A says, at the end of the first day, the amount of bacteria was about, which means approximately, 1560 or 1560. So for this one, at the end of the first day, that means that I would be plugging in the number 1 into the function. So if I plug in the number 1 to represent the day and I type this into my calculator, I'm going to get approximately 1560, which means that the answer to this first question would be true. So question B says, at the end of the second day, the amount of bacteria was about 1622. So this one's asking me about day 2. So I'm going to use the same function, but instead of plugging in the number 1 to check and see if this one's true, I'm going to plug in the number 2. So the number for the number of days is going into the exponent. And so for this one, I get 1,622.4, but you see how it says about 1622? So I can also conclude that based off of the information that I was given, that that question is also true. So the math that I'm doing is checking to make sure that these are the answers to the questions. Question C says the initial amount of bacteria was 1,500 with a growth rate of 4%. So to answer that question, I want to look at the function that was given, 1500, 1.04 to the x. On this one, I'm not plugging in a number for x. Remember, when you're doing exponential functions, this is the number that you start with, and then this is the number that it's increasing by. .04 means you turned 4% into a decimal and you added it to the number 1. And so that's how you know that this question is also true. Both of those pieces of information are true about the question. Question D says the initial amount of bacteria was 1,500 with a growth rate of 1.07%. And so you know that this one can't be true because the growth rate was 4%. That was accurate based off of the question. And so for this question, you can conclude that the growth rate is incorrect. It's the growth rate should be 4%, and so this one's false. It had the correct initial value given, but it had the wrong growth rate given. Question number 10 is another word problem. It says a used car costs $2,000 and it depreciates. You want to make sure that you know that depreciates means that it goes down in value by 6% every year. So it's going down by 6%. The first question wants us to write an exponential model that represents the situation. A lot of people are great at writing y equals, and then a lot of people can remember that the 2,000 goes out front. But where many students struggle is coming up with the number that goes inside the parentheses. If it's going down by 6%, remember your process is you're going to turn that into a decimal. So 6% is going to turn into 0.06, but that's not the number that goes inside the parentheses. It's going down. So to figure out the number that goes in here, you're going to do 1, take away that value. And so the number that goes inside the parentheses on this one is going to be 0.94. Probably want to make a note on how you got this. You did 1 take away 0.06. And so that gave you the value that went in here. Remember that if it's going down, the number inside the parentheses has to be between 0 and 1. And so that's how I knew I was going to subtract the 0.06 from the number 1 instead of add it to the number 1. Question B says, use the equation to find the value of the car in 5 years. So for this one, I'm going to take the equation that I just came up with, and I'm going to plug in the number 5 because I want to figure out how much the car would cost in 5 years. You'll probably, it's common when you do these that you get decimals that need to be rounded. Remember that you're talking about how much something costs, and so you want to make sure that you round your decimals to 2 decimal places. So anytime it's money, you're always going to round it to the nearest hundredth. So for this one, when you type this into your calculator and you round it to the nearest 2 decimal places, you're going to get $1,467. And then rounded, it's going to give you 81 cents. Before I move on to the next question, the car started at $2,000 and it was going down by 6%. So I want to encourage you, if you did this problem and if this number was higher than the number that you started with, you would know that that meant that you had to have done something wrong. It told you that the car was going down in value. So that doesn't mean you can just think about what the answer is going to be, but you do know that the number that you get here after 5 years needs to be less than the number that the car started at since it was depreciating in value. Question number 11 gives us 2 functions to consider. It wants us to start by making tables for both of them. So here's my table for f of x. That's my first one. I'm going to do that one in black. And then this is my table for g of x, my second one, and I'll do that one in red. So when I plug in a 0, 2 to the 0 power is equal to 1. Anything to the 0 power is equal to 1. 2 to the first power is equal to 2. And then 2 to the second power is equal to 4. So those would be my values for my first one. On this one, I'm plugging the same numbers in. But then after I get out that value, I'm going to add 4 to each one. So 2 to the 0 is 1, but 1 plus 4 is 5. 2 to the first is 2, but 2 plus 4 is 6. And then 2 to the second is 4, but 4 plus 4 gives me 8. Part B wants me to graph them both on the same graph, so I'll graph them in the same colors that I just wrote them down on my table. So this is what my first one's going to look like. And notice how I was careful, even though I didn't have points over here, I knew there was going to be an asymptote. There was going to be a place where that graph didn't cross. So I chose not to have it cross down here into quadrants 3 and 4. And then for this one, 2, 3, 4, 5, 6, and then the 8 actually doesn't fit on the graph, but I'll just kind of aim it for where it would need to go. So you guys, this graph is being moved up 4 units, which means that when I draw the line on here, it's never going to cross the line where y equals 4, because this one never crossed the line where y equals 0, so this one would never cross the line where y equals 4. They want me to describe the transformation from f of x to g of x, and so I'm going to say that g of x is transformed up 4 units from f of x. So to get from f of x to g of x, I moved the graph up 4. That's what this plus 4 on the outside did. Question number 12 is a similar question. On question number 12, I'll do the same thing with the 2 colors, but on this one, the transformation is going to be a little bit different. 3 to the 0 equals 1, 3 to the 1 equals 3, and 3 to the second power equals 9. So that gives me my numbers for my first graph. And then for my second graph, 3 to the 0 is 1, 1 times 2 is 2, 3 to the 1 is 3, 3 times 2 is 6, and then 3 squared is 9, and 9 times 2 is 18. So that gives me the numbers for my second graph. And then I'll graph them. So 0 goes with 1, 1 goes with 3, and then the next one actually doesn't fit because my graph only goes up to 7, so it would just be steeper up here. And then notice how when I draw it, I choose not to have it cross into quadrant 3 because I know that there's an asymptote for the graph there. And then for this one, 0 goes with 2, 1 goes with 6, and then 2 goes with 18 also wouldn't fit on my graph. So this one would be located here. They kind of end up lining up over here after a little bit. So that you can just draw it so that it looks like there's 2 of them on the graph. And then they want me to describe the transformation between them. So on this one, g of x is a vertical stretch by 2 from f of x. So to get from g of x to f of x, it's being stretched up times 2. It's not that it moved up 1, it kind of looks like it did. But what's happening is that the 2 out front here is multiplying all of the outcomes by 2, so it's stretching it, so it's getting taller, faster. That's how those 2 graphs compare. Question number 13 is the last question on the review. It says Kevin has $900 invested in his savings account, and he's looking at 2 different savings plans. So under plan A, it says he'll increase his account balance by $75 each year. Write an equation for the amount of money that Kevin will have. So there's a couple different ways that you can write this. One thing that you want to notice is that he's just increasing it by $75 each year. There's nothing being multiplied. He's simply adding $75 to his account every year. So if you were going to write this in y equals mx plus b format, he's increasing his account, by $75 each year, and he started with $900. Remember from back when we learned about y equals mx plus b, the number that goes in front of the x is the number that it's your slope, but it's the number that it's changing by every, increment. And then the number that goes at the end, the plus b part, that's whatever it started with. So the $900 up here is the amount that he starts with. So that's his starting value. B says under the other plan, he'll increase his account balance by 15% each year. When it says that he's increasing it by 15%, that's how you know that this is going to be the exponential function. So this one was a linear function, and then this one is going to be an exponential function. He starts with $900, and then it says that every year it's going to go up by 15%. So you turn 15 into a decimal, 1, 2, and then you add it to the number 1 since it's going up. And so that's your exponential function. Question C asks us to figure out how much more under Plan B will Kevin have in his account than Plan A after 4 years. So we're expecting that when we figure this out for 4 years, this number should be lower than this number because the way that this question's worded makes it sound like the exponential one's going to have more money. It might be best to do this on a separate piece of paper, but I'm just going to try to squeeze it in. So under plan A, y equals 75 times, we're doing 4 years, so we plug in the number 4. 75 times 4 gives me 300. And so under plan A, he would have $1,200 after 4 years. And then under plan B, I'm also plugging in the number 4, but I'm plugging it into my second equation here. And so for this one, when I plug those numbers in and I round it to the nearest 2 decimal places, it works out to be $1,574.11. Neither of those is the answer to the question because it wants us to figure out how much more money he's going to have under plan B than plan A. So if he has this much under plan B and if he has this much under plan A, I would take the two numbers that I get here and here and I would subtract them to figure out the difference. So $1,574.11, take away the smaller value, take away 1,200. If you subtract those two values, he's going to have $374.11 more under plan B than plan A after the 4 years of him collecting money based on these two different amounts. So to find the answer to the question here, you take the bigger answer, you minus the smaller answer, and so your answer for this question should be positive since you're trying to figure out a difference.